Hello class, good morning once again and welcome back to our class here in ESci132, your mechanics of deformable bodies. And as we continue our topic, we are again on our third chapter, which is your axial loads. And previously we have discussed, discussed last week, first your Saint Venant's principle, and second is your load and displacement relationship. So we have created an equation that correlates your load and your displacement, which is your displacement is equal to P or N L over A times E. That is a very important equation once we are dealing with axial loads. Okay, so always take note about that one. And now, we are now on our new topic, and we will now be talking about statically indeterminate axially loaded member. So, unsa man na ang statically indeterminate axially loaded member? Oy. So that is our goal for this morning. So for our objective, we should be able to know what are statically indeterminate axially loaded members. And second is how to solve problems nga kanang naay mga systems nga statically indeterminate members. So, yun ang atong goal karon. Okay? So, unsa man ang statically indeterminate axially loaded member? Sige. So, look at this example. Okay, so look at this situation. We have a column that is fixedly supported on both of its ends. So your end A and your end B. And there is a force of 500 newtons that is exerted at this location, which is, they say that this location is located 3 meters from B and 2 meters from A. Okay? And our goal is to determine your force A and your force B. Okay? So, on your knowledge in statics, how can you solve for your force A and your force B? Your forces A and B are the supporting forces on your points A and B. Diba we usually use the equilibrium equations, right? So, sige daw. Can we use summation of forces along the x here? No, we can't. So, this is 0 because we don't have any x components. Can we use summation of forces along the y here? Siguro we can say, so mao ni ang atong kuan, atong beam, kiingon ta nga ing ana. Sige, so that is FA plus FB minus 500 equals to 0. Diba? Sakto? So this is your equation sa imong y. How about sa imong moment? Summation of moments. Let's say mag-moment ta at point B. Counterclockwise ang positive. Can we create a moment here? No. We can create a moment kay diri ka nag-moment and then we don't have any moment arms. So, this is also 0. As you can notice on our equilibrium equations, we have on our summation of Fy 2 unknowns. And the problem is that when you have two unknowns, you should also have two equations to solve for the two unknowns. But we have a problem here because we cannot use this one and we cannot use this one. So we only have one equation to solve for two unknowns. And this is what you call a statically indeterminate axially loaded member. Okay? So, therefore, a statically indeterminate axially loaded member are those members that cannot be solved only by using the equilibrium equations that we have known already. You cannot solve this one by only having your fx, summation of forces along the x, summation of forces along the y, and summation of moments at point B. Okay? You need another equation nga wala na naglabot aning tulo ka equilibrium equations. And we still have another equation that we can use. And let us make use of our deformation. Okay, sige, let's make use of the deformation sa atong nahibawaan diri. What is the total elongation of this beam after your 500 newtons is loaded? What is the deformation of your A with respect to B? As you can see in this figure, nagbutang tag 500 newtons. Unsa man ito nahibawaan? Since naka-fix man siya at points A and B, what will happen? Unsay deformation aning atong beam? Wala siya deformation. Okay? We have created an equation outside of our equilibrium equations, and we made use of the deformation that we have learned. And this is what you call your compatibility. Or your kinematic condition. And usually, I call this one compatibility equation. So, this deformation, the deformation of your A with respect to B is your compatibility equation. And what does this mean? So, pasabot ana. So, ato tan-awon ang deformation each segment. So, this is your segment A, this is your first segment, and this is your second segment. Ngano nag-segment man ta? Because lahi ang internal force ani nga segment, and lahi ang internal force aning atong second segment after your 500 newtons is loaded. Okay, sige. So, ato tan-awon. Kani kung tayo nga segment diri, this is what you call your FA nga segment. And kaning segment nimo diri, this is what you call your FB nga segment. Okay? Sige daw. So, what will happen? Sige. Ato i-imagine ang deformations aning atong duha ka segment, segment 1 and segment 2. Sa imong A, unsay mang imong ma-notice dere? 'Di ba? We can imagine nga ang kaning atong support dere iya gibira ang kaning atong 500 newton nga load para mo equilibrium siya. At the same time, dere sa imong B, iya gi-push kay para ma-equilibrium pod siya. So, therefore, what will happen to your first segment, your segment A? Kani siya, moinat siya. So this one, this segment here, will elongate. Okay? Because this one is subjected to tension. Okay? How about on your second segment? This segment is subjected to compression. So therefore, this will compress. So, unsay mo himuan nga equation ani? Your elongation at A, positive siya since it elongates. And since this one will compress, then this is minus. Minus your deformation at B. And the total of the deformation of A to B is 0. And now, we are going to use our load displacement equation. So, itong load displacement equation, that is your NL over AE. Okay. Okay. So, direta una sa A. Ni-elongate ang atong A. So, Ang internal force dere, wa man takibaw because this is still unknown. FA times the length of 2 meters over cross-sectional area. Way gihatag nga area, so A times E. Minus, kaning B na pod, FB times 3 meters over area times modulus of elasticity. Okay, so now you have your first equation and your second equation. We can simplify this one further. Why? Ato ibalhin. So, FA over AE times 2 meters equals to FB times 3 meters over AE. So, this is cancelled. And ang imo lang nabilin kay FA times 2 equals to FB times 3. Ato na po ni oh my gosh! Ato na po ni balhin, pastilan. May pagwala dito na huwag ibalhin. 2 meters minus FB 3 meters equals to 0. So, we can use this one. We can calculate your FA and FB using this equation. And by using your knowledge in solving two unknowns using 2 equations, you will arrive of the answer for your FA as 300 newtons and for your FB as 200 newtons. Okay? So we have solved the problem. We have learned nga the forces nga nag-support sa atong A ug sa atong B is 300 for FA and 200 for FB. So, again, we cannot solve this problem by only having your equilibrium equations. But since we have learned another equation that we can use, which is your compatibility or your kinematic condition equation, then you can still solve this problem. Okay? Take note, ang imong compatibility equation will depend on what kind of situation ang gihatag sa imo. So, dapat imo igamit ang imong utok sa pag-analyze kung unsa ang deformation nga nahitabo aning atong beam or aning atong column. Okay? So, lahi-lahi ni siya. Dili lang ni siya ing anira kanunay. Okay. Sige. Let's have a legit nga example. Kani kay di man ni legit. So far, have you understood? Okay? So, this requires practice. Okay, let's have this example. We have this steel rod. Okay? And kani nga steel rod, this is fixedly supported at A, at wall A. And naapod tay another wall sa pikas, which is your B prime nga wall. Pero wala siya naka-fixedly attached dira sa atong B prime. Pero na siya gap of 0.2 millimeters sa ani nga wall. Okay? And there is a 20 kilonewton force applied at point C, which is 400 millimeters from point A. And it is assumed nga inig-push nimo aning 20 kilonewtons, musangko na siya diri sa atong wall sa B prime. And the question is, what are the reactions at point A and B prime? So, what are the forces na po diri sa atong A o sa atong B prime? After ni, sangko na diri sa atong wall. After sa pag-apply sa atong 20 kilonewton nga force. Okay? And it is given here nga ang atong steel rod has a diameter of 10 millimeters. And the modulus of elasticity of our steel is 200 gigapascal. pascals. Okay? So these are the given. And again, required to solve for the forces or the support reactions at point A and B prime. So, as you can see, lahi na po ding atong compatibility equation up ani. Kay, naman po siya gap. Kagani hawa mo siya gap. Okay? Okay. So, sa equilibrium equations ng atong nahibawaan, which one ang magamit lang aning situation? Can we use summation of forces along the x? Yes, we can. Because we have forces that are oriented on the x-axis. Can we use summation of forces along the y? No, we can't. Why? Because we don't have any forces that are oriented on the y-axis. Can we use summation of moments of this one? No, because the forces are collinear with each other and also on our moment axis magtagbo pod sila. So we can use only your summation of forces along the x. And therefore, this one is a statically indeterminate axially loaded member. So, summation of forces along the x, going there ang positive, is equal to, ato itawag FA o niya FB gyapon. So, ato i-imagine, sa atong A, unsa may reaction diri sa atong A, should it be going there or should it be going there? Since atong force nga 20 kilonewtons is going there man, para ipugong sa atong support at A, it should be going to the other way. Okay? How about at point B, assuming nga nisangko na ni siya? So since your force 20 kilonewtons is going that way, then your support at B should be going on the opposite direction. Therefore, it should be going that way. So, let us just change the assumption sa atong direction kay para mapositive ang atong A ug B. Ito na lang i-go to the left. This is equal to FA plus FB minus 20 kilonewtons is equal to 0. And this is your first equation. Now, since again, this one is a statically indeterminate axially loaded member, then wala na ito'y gamit ang atong summation of forces along the y and summation of moments. So, we have to create a compatibility equation or your kinematic condition nga equation. So, tanawa ang kaning atong rod. Unsa man ang deformation nga mahitabo sa aning atong rod? Or in general, ang deformation sa atong A to B. Sige. Deformation of A with respect to B is equal to. Sa atong first ay sa atong katong akong pinakauna nga example, 0 ang atong deformation. Why? Because the ends are fixedly attached to the wall, pero di to wall kay vertical man to. Pero kani naman siya gap nga 0.2 millimeters. So therefore, instead of having it 0, dire na pod 0.2 millimeters. Okay? So, ni-deform siya by 0.2 millimeters. So, unsa may nahitabo dire? Ni-elongate ang atong A. So, therefore, positive atong A. Dire, ni-compress ang atong segment CB or aton lang itawag ni nga B minus B is equal to 0.2 millimeters. Okay. So, ato na naibungkag. So, your segment here has a force of FA and your segment here has a force of FB. Take note ha, these are internal forces. Okay. So, this is FA times 400 millimeters over area, which is diameter, so pi times 5 millimeters squared times modulus of elasticity. This is 200 kilonewtons per millimeter squared. minus FB times 800 millimeters over area pi times 5 millimeters squared times 200 kilonewtons per millimeter squared. This is equal to 0.2 millimeters. Check for the units. Millimeter, 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 millimeter. Oh, sa tanan diri is millimeter. Kilonewton, kilonewton. So therefore, ang answer dapat nato diri sa FA ug FB is kilonewton pod. And since kilonewton ang pod diri, so to be uniform, so kilonewton atong gamiton para ma-solve natong FA ug FB. And this equation right here is your second equation. Okay? And by using your calculators and your knowledge in algebra, you will arrive on the answer that your FADI, your FB, is equal to, for your FA, 16 kilonewtons, and for your FB, 4.05 kilonewtons. Okay? So, understood? Kamo na lang calcu ani. Di ba, magamit namin sa calculator. You can simplify this one. Imo i-simplify ni siya. And, kani. Imo ni i-simplify kani siya. And then, kani pod imo na i-simplify. And then, gamiton nimo sa calculator kadtong two equations and two unknowns that I've taught you on your statics, and then you will arrive on this answer. Okay? So if you still don't know how to solve two equations and two unknowns on your calculator, you may ask me, or you may ask your classmates nga nakibaw. Okay? Okay. So let's have this another example. We have here this post. This one is an aluminum. Okay? Ang kaning blue, aluminum din siya. Ito tanaw sa top view ha. Aluminum na siya. Okay? And kaning atong aluminum nga post, gi-reinforce siya with a brass nga core. So this one is your brass, and this one is your aluminum. Okay? And kani siya nga post, sa babaan nila gi-attach siya og kaning atong rigid nga plate. Okay? So rigid ni siya. And this rigid plate is subjected to 9 kilopounds of force. Okay? So kani day siya tabunan ni siya og rigid nga plate, and then ang kanang rigid nga plate gi-subject to 9 kilopounds nga force. Okay. The problem is, you have to determine the average normal stress of your aluminum and your brass. Okay? So, mo na tong goal. So, unsa man ni pag-solve? So, let's imagine here, what are the forces that are acting on this post? We already knew that there is a force that is acting on our brass, and also, there is a force that is acting on your aluminum. Okay? And kani atong aluminum, well, of course, diri siya sa area sa atong aluminum. Ang kaning brass, diri siya sa area sa atong brass. Okay? So, therefore, what are the equilibrium equations that we can use? Can we use summation of forces along the x? No, we can't. Why? Because we don't have any x component nga force. How about summation of forces along the y? Well, of course we can. Summation of forces along the y, going up ang positive, which is equal to FA plus FB, minus 9 keep equals to 0. And this is your first equation. Now, how about for the moments? Now, nga, atong A is distributed ni siya diri sa atong kuan ha, itong area. So, it is assumed nga naa siya diri gapon sa tunga. So, therefore, if we are going to use summation of moments, then we cannot use summation of moments because, again, they are all collinear. Okay, so therefore, mao lang ni ang equation nga atong magamit. And we have to use a compatibility equation or your kinematic condition equation. Now, unsa may pag-solve? Unsa na po atong compatibility equation ani? Since these two, di ba kay ang ubos ani kay kuan man floor, rigid nga floor. And diri sa babaw rigid pod ni, so imo gi-deform ang babaw ug ubos. And we know nga mo deform ni siya. And unsa may relationship sa deformation sa atong aluminum ug brass? They are equal. So therefore, your deformation of your aluminum is equal to the deformation of your brass. Okay? So mao ni atong ma-observe sa deformation sa atong aluminum and brass. Since they are since ang end sa atong ubos is supported on a floor, ang sa atong babaw gibutangan og rigid nga plate, therefore we can say that the deformation sa atong aluminum ug sa atong brass is equal. Okay, so let's use this one. FL over AE, FL over AE. So, okay, so your force of your aluminum multiplied by the length of this one, which is given here 1.5 feet, pero ang ato lang gamiton is in inches. So, 1.5 times 12, this is 18 inches over your cross-sectional area of pila tong area sa aluminum. So take note, this is pi times, since this one is a hollow aluminum, so outer area minus inner area. Okay, so unsa man na? Pilang outer diameter? Outer radius ni gihatag. 2 inch squared minus 1 inch squared. So this one di ay is 2 inches and this one is 1 inch. Okay? And your modulus of elasticity is 10,000 kilopounds per square inch. Okay? Sunod. Is equal to, punta sa bronze, FBR times 18 inches over, since di naman siya hollow, so therefore, pi times radius of 1 inch squared times modulus of elasticity of your bronze, which is 15,000 kilopound per square inch. And if you are going to simplify this one using your calculator, you will arrive on this value. Aluminum is equal to 2 FBR. Okay? And now this is your second equation. So unsaan ganini pag input sa calculator, dapat ang imong ang form sa imong kuan is F aluminum plus F BR is equal to 9 kilopounds. Yeah, ang second equation. So this is your first equation ha. For your second equation, F aluminum minus 2F Br is equal to 0. So this is your second equation. And therefore, by using your calculator, you can solve for your F aluminum as 6 kilopounds. And for your bronze, 3 kilopounds. So now we have solved for the reactions at your aluminum and your bronze. But we are not done yet because what is asked is what are the average normal stress on your aluminum and your bronze. So, patanahuman. So what are you going to do? Well, simple. Your average normal stress of your aluminum is equal to normal force, which is 6 kilopounds over your cross-sectional area of sa to, pi times 2 inch squared minus 1 inch squared. Okay, so pila man eh? So your answer is 0.637 KSI for your aluminum. And for your brass for your brass, this is 3 kilopounds divided by pi times 1 inch squared, which is equal to 0.955 KSI. So these are your final answer of this problem. Very easy, right? Now, let us have another one. Last example. Daghan na tong example because there are a lot of situations nga maka-apply kag lain-lain nga equilibrium ay lain-lain nga compatibility equation. We have three steel bars, this one, and this one. And these three steel bars are pin connected to this rigid member. Okay? And if a load of 15 kilonewtons is applied to this point, then we are asked to determine for the forces developed in each of the three bars. Given now that your bars AB and EF have a cross-sectional area of 50 millimeters and your bar CD has a cross-sectional area of 30 millimeters. Okay? So, ang atong ipangita karon kay ang forces at AB, CD, and EF. Okay. So, may atoon na buhaton. Atoon na buhaton ato gamiton ang tulo ka equilibrium equations. So, maghimo sa tag free body diagram. So, this is your free body diagram. And I know nga ingani ang direction sa atong forces. Okay? Iya man gipugong ang atong 15 kilonewtons. So, therefore, summation of forces along the x, we cannot use along the x because we don't have any x component. So, summation of forces along the y tadayon is equal to FAB plus FCD plus FEF minus 15 kilonewtons is equal to 0. Can we use summation of moments? Yes, of course, we can use summation of moments here. Summation of moments at point A lang siguro ta. And assuming that the direction, this one is positive. Okay, so diri ta nag-moment ha, diri ta nag-moment. So unsa man na? Una ta sa CD. FCD times moment arm of 0.4 meters. Positive, right? Kay create siya counterclockwise. Sunod, plus FEF times 0.4 plus 0.4, 0.8 meters. Minus 15 kilonewtons times 0.2 meters is equal to 0. Una lang bagitay duha ka equation ani. Makasolve na ta ani gamit ang duha ka equation. No. Ano naman? Tulo atong unknown. So if we have 3 unknowns, then we should have 3 equations. And we only have 2 equations here. So this one is still a statically indeterminate axially loaded nga member. Okay? So this one is your equation number 1. And this is your equation number 2. Okay. So now, unsaan namin na nato diri ang atong compatibility equation. This is kind of tricky kay tulo na. So unsaan man nato. Okay, let's imagine this is the undeformed ay wala pa ni displaced nga bar. And let's say this is your displaced bar na. And naman tayo example ani sa una no. So in this one we can create a triangle out of here. And this length is, let's call this one as delta EF. Right? And let's call this one as delta AB. And this one, let's call this one as delta CD. So how are these 3 deltas related with each other? They are related with this triangle right here. Because we have learned that this one lies on the same slope. So all of these 3 deltas here are related with the same slope. Okay. So, okay, ato mag-focus sa nga triangle. Okay. So, unsa man ni siya nga length? Unsa ni siya nga length? This is delta AB minus delta EF. Sakto? Kay kanima na siya nga length, di ba? And then this one is delta EF. So, delta AB minus delta EF. How about this one? This is delta CD minus delta EF. So therefore, we knew that this one is 0.4 and the other one is 0.4. And because they have the same slope, therefore we can use the same slope nga formula. Unsa man to? Rise. So delta AB minus delta EF over run of 0.8 is equal to delta CD minus delta EF over 0.4. Now, simplifying this one further, delta AB minus delta EF is equal to 2 times delta CD minus delta EF. Okay. So, unsa naman na? Ito pa i-simplify. Okay, pastilan ako ng ito gidiretso. delta AB minus delta EF is equal to 2 delta CD minus 2 delta EF. Okay. So, noon sa namin si Ja, ibalhin na tong EF dira sa may mabilin. Delta AB plus delta EF minus 2 delta CD equals to 0. Okay. So, this is our compatibility equation. And, sige, ato na ni gamit sa atong force displacement nga relationship. FAB times 500 millimeters over 50 millimeters squared times modulus of elasticity. Ato lang ibutang nga E still. Makancel naman ni siya later on. Next. Plus FEF times 500 millimeters over 50 millimeters squared times modulus of elasticity of steel. Also, ato lang i-transpose ni Hake para kuan, para legit. 2 times FCD times 500 millimeters divided by 30 millimeters squared, squared times E steel. As you can see, actually, makancel ra ni ang atong steel. Diba? Kay ini-transpose ni mo ani dere. Kay diba? Imo na igawas. And then, inigawas ni mo ana, makancel ang steel. And actually, kaning 500 millimeters, makancel po na sila kung imo na sila gawas. Okay? And now, if you are going to simplify this one, you will get that ang simplified ani nga form is 0.3 FAB minus FCD plus 0.3 FEF equal to 0. And this is your third equation. And now, you already have 3 equations to cater your 3 unknowns. Then, calculating using your calculator, you will get that the answer of your FAB is 9.52 kilonewtons. For your FCD, 3.46 kilonewtons. And for your FEF, your answer is 2.02 kilonewtons. And these are your final answers. So, ing-ani lang ang pag-solve. Ang critical lang dire sa pag-solve ani is to create your compatibility equation. So, if you still didn't understand how to make compatibility equation, then there are still a lot of problems nga pwede ninyo mapraktisan. Okay? Because this is very important, ang compatibility equation. They differ depending on what situation they are in. So, it's better for you na inyo imagine unsay relationship sa displacement sa inyong nakitaan nga figure. Okay? So, this is how you solve problems that are statically indeterminate. Okay? So, as a summary for this lesson, first, you already knew what are statically indeterminate axially loaded members. So, we have here 4 examples of what are statically indeterminate axially loaded members. And you also knew how to solve for those unknown forces and unknown stresses on a statically indeterminate nga members. So, please practice and please study more about this one because this one is tricky. And if you have any questions, you may ask me on Messenger or on the comment section down below. So, we still have another lesson later on, and please keep in touch. So, see you later, alligator. Bye.